Hi everyone, it's Mr. Roden. In this video, we will take a journey through kindergarten to college, and we will answer the following questions. Why was math created in the first place? What is the difference between arithmetic and algebra? What is an equation? And what does it mean to find the solution to an equation? And lastly, why do we need graphs? Okay, let's begin. First of all, since you're in my Math 110 or Math 115 class, you are here. You are in college. But let's look back at what you're supposed to have learned leading up to college. From kindergarten to 5th grade elementary school, you spent most of your time learning what's called the operations. The basic operations of addition, subtraction, multiplication, and division. And you did it with whole numbers, and then you had to learn how to do it with fractions and decimals. So if you remember back in those grades, you were adding, subtracting, multiplying, and dividing. Okay? Now, somewhere in middle school, you learn more operations, powers, square roots maybe, and maybe basic geometry. You know, rectangles, triangles, circles, parallelograms, trapezoids. Okay? Now in high school was, for most people, the beginning of what's called algebra. Algebra 1 maybe, and then more geometry. And maybe, if you were a little bit advanced, you also did trigonometry, where you learned about the properties of triangles and maybe the equations of sine, cosine, and tangent. If none of this is familiar to you, that's okay. I myself did not take trigonometry in high school, and look where I am today. I have a master's degree in pure mathematics, but I did have to learn it in college because I missed it in high school. Okay, so where are you at now? Math 110 is probably the last math class for non-science majors, business, and all other types. This would be the end of the road for you. But for those of you in my Math 115 class, this is the beginning of the road for you. You're going to have to take Math 161 A and B, and then maybe if you have a 4-year, you're pursuing a 4-year degree, go to UOG, and then you're going to have to take calculus. Okay, so for science type majors, engineering, computer science, you're going to have to do more than Math 115. But I am assuming, because you came from kindergarten all the way through 12th grade, that you've got a firm grasp on all these operations, powers. By the way, order of operations is a huge part of arithmetic leading up to algebra. Okay? So in our class, we're going to do a little bit of algebra again. There's always going to be algebra. It's college algebra this time. Before, you were learning about straight lines and maybe quadratic equations. But there are many more equations that we're going to learn, especially in my Math 115 class. There are exponential equations, polynomial equations. So we're going to learn that. That's college algebra. Moving on to the next question. Why was math created in the first place? Before we take our journey into college algebra, you really need to understand this question. Okay, I will begin to answer this question by asking you, how many tick marks do you see up here? Okay, if you said 17, you are correct. Now, math was created to count things. Let me repeat that. Math was created to count things. Okay, now how many of you counted it? And there's a lot of ways to count things. How many of you counted this one at a time? If you counted, you were actually using repeated addition. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You're actually adding 1. That's what counting is, by the way, to get 17. Now, some of you might grouped it together. There's 3 groups of these little 5 tick marks, and then you added 2 at the end because you saw 2. That's also another way to add them. So math was created in the first place to count things, but look at the way I wrote these are 2 different ways. We need to make sure everybody in the world does it the same. That's why we needed to learn order of operations. Everyone in the world who studies math knows order of operations. You're supposed to do multiplication and division before you do addition, okay? You do not go 3 times 5 plus 2. The answer here is not 21, okay? That's wrong. So, throughout the semester, ask yourself, what are we counting now? Every chapter has different equations in it. Now, the most important thing we are counting right now in our world, and you will see this graph a lot in the news, is our coronavirus pandemic. We're counting the number of cases. Okay, that's what it means to flatten the curve. They don't want this to be rising up. They want it to flatten out and be less. You will learn in this class that this is called an exponential equation. Okay, so you're going to learn that equation, the properties of that equation, and the properties of the graph. There are about 7 or 8 different types of equations in Math 115, and a little bit less in Math 110. But there are different equations, starting with the straight line equation and the x squared equation. But there's more. There's a log equation, polynomial equations. There's a lot. Okay, so we'll be studying all of these. But remember, both my Math 110 and 115 class, always ask yourself, where are we going to use this in real life? I just showed you right now that the exponential equation is used to count coronavirus cases. And the graph of that shows a picture representation of that. Okay, now, question. What's the difference between arithmetic and algebra? It's actually quite simple. Arithmetic is numerical calculations. Oops. And algebra has variables, variable expressions. Okay? This is an example of arithmetic. You don't see any variables in here. This is a math statement. 2 plus 3 is equal to 5, period. Algebra is the beginning of math questions. What number plus 3 is equal to 5? See, this is a question. You have to figure that out. Obviously, the answer is 2. So that's the difference between arithmetic and algebra. Next question. What is an equation, and what does it mean to find the solution to an equation? Okay, first of all, an equation is a statement that 2 quantities are equal. Let me repeat that. An equation is a statement that 2 quantities are equal. An equation always has an equal sign. That's the sign that it's an equation. Okay, 2 plus 3 is equal to 5. Is this an equation? 2 plus 3 is equal to 7. Yes, it is an equation. It's just not true. So you've got true equations and untrue equations. Is this an equation? No, it's not an equation, but it is an inequality, a different type of math statement. Okay? We will be studying inequalities in Math 110 and 115, but most of the time it's equalities. Okay? And now, is this an equation? Of course. There's an equal sign, and it's saying the left side is equal to the right. This is an algebraic equation. Now, algebraic equations are questions. What number plus 3 is equal to 5? You have to answer that. So finding the solution is finding the value of the variables that will make it true. So when you're finding the solution to this, we'll study this later, but you know the answer is 2. By plugging it in, 2 plus 3 is equal to 5. You have restored the truth to it. Okay, so x equals 2 is the solution. So finding the solution to an equation means finding the values that will make it true again. Now we've got equations in one variable, and we also have equations in two variables. Now the thing with two variables is, what are the solutions to this? There are many. There's 0 plus 5, 1 plus 4, 2 plus 3. There's so many, right? 3 plus 2, 4 plus 1, all of these. Infinite amount of solutions. Now, when there is an infinite amount of solutions in math, we need to find a way to list them all, and we cannot sit here and write down all the solutions to this. So we need to find a way to represent it, and this is what a graph is for. Which actually leads us to the last question. If you plot all these points out as coordinates, this is section 1.1 in Math 115, etc., forms a straight line. Okay? Which leads me to my last question. Why do we need graphs? Now, students think this is a supplementary thing. Graphs are just extra. They are not extra. Graphs, I will repeat this, and you need to understand this. Graphs are the solutions to an equation or an inequality. They are not a separate thing. They actually are the solutions. We cannot sit and write all of these down. There's an infinite amount. So we need to show it with a graph. The graph is actually telling you the solution. The graph is the solution. And again, I will repeat this one more time. Students don't understand that graphs are actually the solutions. When I ask you, solve this equation in two variables, how do I do that, Mr. Roden? You're not going to sit there and write down all the solutions. You're going to have to draw the graph for it. So drawing the graph of an equation is equal to solving it. Let me write that down. That's a good one. I never thought. Drawing the graph of an equation is equal to solving that equation. Remember that. Understand that. Okay, so that's why we need graphs. Now, in this Math 110 and 115, we're going to be studying many different types of equations. So, and where they're used in real life. So you need to identify what type of equation it is. For example, y equals mx plus b. You need to know the name of it. It's called the linear equation. You need to know the graph of it and all of its finer points, the y-intercept, the x-intercept, the slope, etc. Every single chapter has a different type of equation. Okay? So let's look. Did we answer all the questions? Kindergarten to college journey? Yes. Why was math created in the first place? To count things. What is the difference between arithmetic and algebra? Arithmetic has numbers, algebra has variables. What is an equation? An equation is a statement that two quantities are equal. What does it mean to find the solution to an equation? It means to find the values of the variable that when you plug it back in, it makes it true. And lastly, why do we need graphs? Graphs are the solutions to equations. They're not just extra things. Okay, now this is a video. You can pause it at any time. You can repeat it any time. This is information you need to know before we start our course. Okay? Bye-bye.